What is up, makers? Welcome back to the lab. Today we have a mailbag video. The mailbag pile has gotten really big, and there's parts in here that I want to use. So we're just gonna dive right in and see what I've gotten in the mail in the last week. First thing on the top of the pile, package from DHL. My guess is this is from our friends at JLC PCB and contains some new PCBs I designed for a project that I'm working on. Not really ready to share what the project is, but, and as usual with DHL, since they like to rob us, they submit every package to the Border Patrol before it even hits the border, asking them if they want to charge duties and import. And the reason that they do this is so that they can tack on their own fee on top of everything else. That way they can double how much they make on shipping. I'm not really a fan of DHL, in case you didn't notice. So we have 30 PCBs. Well, not really vacuum sealed the way the JLC PCB stuff normally is, but very, very simple PCB. Once again, the quality that I expect from JLC. There'll be a video coming up very shortly on what these are and using them in an assembly. Cool. I'm just going to use the JLC PCB box for everything that shows up for this project. Alright, next we have a mystery package. I think I know what it is, but let's find out. Yep. We have battery tabs here. Huh. I didn't think the ones that I ordered had springs to them. Alright. They're supposed to be for 18650s, but these look like they're for AAAs. I'll have to check the order and make sure that I'm getting what I believed I was getting. And these were just for general use for projects around, so when I wanted to use the 18650s, I didn't have to solder them in place. I could have them be removable. We'll look into whether or not this is exactly what I ordered, and if it's supposed to have springs and be this tiny. Alright, so moving right along. We have a package from our good friends over at 3D Printing Canada. I know what this is. I'm right. This is going to be transparent PC Plus filament and transparent PETG filament. I'm working on an experiment to see if we can 3D print light pipes. Light pipes are usually pieces of acrylic that allow you to shine a light in one end and have it come out the other. Basically a thick fiber optic. One of the projects that I'm working on, the one that the words are for actually, I want to be able to channel light to specific spots. And I have a feeling that this is going to be harder than I think it's going to be. But one of the first tests I wanted to do was to go ahead and figure out what type of filament I can make the most translucent and the most transparent by changing printing parameters, layer heights, what direction it prints in, the thickness of the layers versus the thickness of the extrusion. I'm going to have a lot of experimenting to do. There will be a video coming up as to whether or not you can 3D print light pipes. We'll find out. Alright, then we have only one other thing in here. Yep. Let's get rid of the box. Get the filament out of my way. acupuncture needles that are 0.4 millimeters. And these are generally used to clean out any clogs that you might have in your in the 3D printing nozzles. So that's essentially what I bought them for. Since putting on the Micro Swiss all metal hot end onto my Ender 3, I don't get as many clogs, but the ones I get are much worse. So I'm hoping that these will do the business and let me clear the clogs in a much faster way. Alright, moving right along. Just tanking through these things. Alright. So, I switched about halfway through whether I was taking the external wrapping off or not based off of the whole COVID thing. So some of this stuff is not in its original shipped package. This, as the outside box says, is a 7-inch LCD display. It is a touchscreen, 1024 by 600 pixels. I had originally purchased this because I wanted to make a teleprompter for one of my other channels where there's a lot of scientific information being presented. There's a lot of things that I want to get right, people's names that I want to get right. But the more I thought about it, the more I thought, it's kind of a waste of this screen, isn't it? I mean, this is a beautiful, beautiful screen. Right, so it has apparently USB power, right, the USB touch controller and an HDMI input. Right, just pretty much a standard screen. Now the interesting thing is we have some I2C communication right here and another USB port there. It'd be interesting to see what those are for. Right, but yeah, I may or may not use this for teleprompter or for other projects that are going around. I wouldn't mind having a slightly smaller floating monitor in front of me here, and that would definitely do it for me. And it obviously comes with mounting hardware, a USB cable, which is probably just for power, and then a very short HDMI cable. Now I think the ad said this was supposed to be used with a Raspberry Pi. I'm just going to use it with whatever HDMI source I think I want. And I might just use an old phone for the teleprompter. I don't know yet. If you have any suggestions, comments down below, man. Alright. So now we have a relatively big package from Amazon. And I know that my little bench camera is not going to do this justice, so we're going to go ahead and hit that. And I'm going to... Okay, so this one still has my address intact, so I would really like to find a marker. Wherever I put my marker. Alright, I'm just going to make sure that when I open the box, the address looks at me. Now I do happen to know what this one is, and it is going to be something awesome. Something that was recommended to me by Adam Savage. Right, and an upcoming build that again I'm not really ready to talk about yet will be a very useful tool for it. So, standard Amazon box, and standard box within a box from Amazon. Clean that up later. Alright, so now my benchtop camera is going to be of some use. Made in China to Canada. I mean, it's made somewhere over an ocean? Alright, let's get the box open. What we have in here is a mini chop saw. Now, I first saw this on Adam Savage's Tested when he was giving a tour of one of his labs. I have a project coming up that's going to be using a lot of 2020 and 2040 aluminum extrusion. And I figured this would be a very easy way to cut that aluminum extrusion and maintain a straight line. if you've been with the channel for a while, you know that I am completely incapable of cutting a straight line over 6 inches. I don't know what these are. These look like almost motor brushes. And then a clamp and some Allen keys for probably replacing the blade. Let's go ahead and see if I can get some of the packaging off of this. All of my tools have moved. So we'll just move that way. Oh, okay. What?
Sorry.
Adam Savage was right. The vise is the weak point here. The vise definitely is the weak point. Now on his, he upgraded his. I don't have a CNC mill to upgrade mine, so it will definitely do the business. And I can't wait to get to know our new friend in the lab here. Alright, moving right along. Alright, we have a whole bunch of something. These are rotary encoders. I'll put most of them back in this bag so I don't lose track of them. I know that they have a lot of little parts with them. I've never actually used a rotary encoder in a project. But it seems like it's a neat method of control. Alright, so I figured, why not just dive right in? Alright, what we have here is a washer. Like so, okay. So if we take a look at the pinout here, let's see if we can figure out what's going on. We have a clock, we have data, we have the switch, which I'm guessing is the pusher, and we have plus and we have minus. So I'm guessing the clock and the data are used for actual rotation, determining which way it's turning and when it pulses. I honestly don't know, but we're definitely going to find out. There'll be a video coming up on how to use rotary encoders shortly. I'm sure that there are tutorials out there, but I'm sure like the button tutorials and the Arduino tutorials using strings, that all of them are wrong. Right? That there's probably bouncing issues with these that tutorials are telling you to take care of in software. Bouncing is a hardware issue. You should never take care of it in software. On that note, there is a video coming up soon. Everything that you've been told about using a button with an Arduino or another microcontroller is wrong. A little bit of hyperbole. I agree. But video coming up soon with a much more efficient way of handling buttons and other types of input into an Arduino that doesn't rely on stopping the main execution of the program in order to debounce the switch. Alright, so next we have another bag of goodies. I believe these are real-time clocks. I went to do a project a little while ago with a clock, and I pulled the last RTC out of my stockpile. These are just your standard DS1307 RTC modules with the power in there. Standard I2C interface. You've seen me use these on the channel before. I just needed some more, so I grabbed some more. Let's keep shucking along here. I've never really been one to use a whole lot of flux paste, but I'm working more with SMD components. I'm working more with rework type situations, so every tutorial says to use flux with it, so I essentially went out and bought some flux. I bought about 5 vials or needles full of the flux. Right, and we will see how well this works. Oh, it comes with a needle point. did not know that. That is handy. Alright. So once again, we'll do some soldering with it, probably on those boards over there, and I'll tell you what I think about the flux itself. I'm going to leave this one right here because now it's part of the tools of the bench. Alright, I think we're almost out of stuff. Alright. So, first thing we have here is a pulse ox monitor. This uses frequencies of light to determine A, what your pulse rate currently is, and the oxygenation of your blood. I wanted this because I was legitimately contemplating what the effect of wearing a mask because of COVID really is to your blood oxygenation level. This has been one of the complaints that people have given me, is that the masks will reduce the amount of oxygen that you have in your blood. So my theory is we'll take one of these guys, we'll attach it to an Arduino, right, and to an SD card, and we'll data log my pulse ox as I go throughout my day. And when I've been wearing the mask for a while, we'll see if my pulse ox actually does drop. Right? Very simple test to answer a very simple question, really. I want to get this back in here because I only bought one. Alright. And the last circuit board. This is a current sensor based on a 219 chip, if I'm correct. Oh yeah, like I have any chance of reading that chip. Yeah. Well, this is the INA 3221, not the 219. So this has 3 channels with 100 ohm shunt resistors, an I2C interface, and this allows you to determine how much current you are drawing through a system by measuring it in parallel of the battery. Neat little device. Yeah, I'll definitely be experimenting with this. I'm using its little brother in a couple of the designs that I've put forward for the projects that I'm working on, which is the 219, which is essentially the same thing except it only has a single channel to it. That'll be neat. And our last product of the day, our last shipment of the day, is this little guy here. Continuing along the lines of getting the buttery smooth 3D prints, 3D print time lapses that we've gotten before. I wanted to see how a cell phone does. So I picked up from Amazon one of these little cell phone remote camera triggers. The idea is that I'll rip it apart, and I'll attach a micro switch to it, and we'll attach it to my 3D printer, and we'll take some time lapses with my phone. Now, I'm not an overly big fan of using my general phone for this because some time lapse prints can take 14 hours, and I really don't want my phone tied up for 14 hours. But I do have an old iPhone as well, so we'll try that. And then we're going to take an Arduino and we're going to try and do one of the buttery smooth time lapses from multiple angles, using the action camera, using a cell phone, and using my main A5100. I think it'll be an interesting effect to be able to switch angles during the time lapse, and we'll get some interesting footage that way. So that appears to be everything that I have received in the mail last week. Links to everything, as always, in the comments down, or in the description down below. If you have any questions, if you have any comments, if you have any suggestions, comments down below. I want to thank you for joining me in the lab today. I hope you learned something, and we will speak again soon.